Yeah, I'm realizing that it was a lot easier when I used to attend these things because I'd stay up till 2:30 in the morning doing other things, and then I could sit in the back of the room and do whatever. Now I'm staying up to 2:30 in the morning doing this stuff and working on other problems for this, and I still have to get up here and act like I'm awake. So if there's any typos or anything funky in this, just take into account it was a little bit late at night. You have to get done by noon because the games start at noon today. Oh, it's, So I approached this with the random match probability. We're one of the labs that we would not subtract out the major for this because it was less on average, less than a 4-to-1 ratio. So problem number one, looking at D8, and this is just a copy and paste from the Excel worksheet that we use. I don't have in here off to the left side, there would be the autofill of the alleles that were present, but then from there it just autofills this. In this case, from D8, there's 3 alleles present, the 12, 14, and the 15. So in the 3 allele middle box there, it gives every combination of how you can have 3 alleles. So then I would just go down through the mixture and say, okay, can it be a 12-12 with a 14-15? And again, I'm basing this on an assumption of 2 individuals. So I'm restricting it or modifying it that way. And then we also restrict it by using the peak height information. So a 12-12 with the 14-15 isn't a viable option because the 14-15 doesn't meet our minimum expected peak height ratio. So I put a little no there. 14-14 with the 12-15, again, same issue. The peak height ratio doesn't match up. A 15-15 with the 12-14, that would seem to work, but then you end up with a mixture ratio, or the ratio is off too much. So we're at the high end like this, which we almost never see RFU values at this level, but at the high end, if the mixture ratio is a 3-to-1, we would give a kind of plus or minus 1. So we'd say it's either a 2-to-1 or a 4-to-1. And as long as the mixture balance fits within there, then we would go with it. In this case, if it was a 15-15 with a 12-14, while the peak height ratios work for everything in there, the mixture balance would be off, and so we would exclude that as a viable option. You look at the 12-14 with the 12-15, again, that's not going to meet the, 12-14, 12-15 is a viable option. The 14-15 with the 12-15 does not work. The 12-14 with the 14-15 is possible, and then there's no possibility for dropout. And this is, again, this is how we document our interpretation before we ever look at a reference sample. So then that's going to autofill the other half of the table. The 2 columns right here, basically that's our list of potential contributing genotypes to this mixture. So you go through, and if you run your reference sample, all you have to do is compare it to this. If he's a 12-14, a 12-15, or 14-15, he's a possible contributor to the mixture. And then, since this is a random match approach, you basically just calculating the RMP for the 12-14, the 12-15, and the 14-15, and that's what's going on over here. And then you just sum it down, and you end up with, at this locus, the RMP is going to be 0.141. Is everybody following that? It's just pretty straightforward. Yes. Can you go to a microphone, please? Sorry.
So one of those should be 14, 14, and 12, 15.
Yeah, that's the second row. Yeah, it's a no.
Why is it a no? All right, I'm looking at the wrong mixture.
Okay,
Sorry,
sorry, yeah, we're going through the same, so what Mike just presented CPE on, I'm going back through and presenting RMP on. That is gonna be really weird if you were doing it the other way. All right. Do I need to go back through this, or? Okay. Now are we copacetic? So basically, we go through all these potential mixtures or combinations. We do the yeses and nos. It's going to autofill this. No, because in this case, we weren't separating the minor from the major because it was less than a 4-to-1 ratio. But we're looking at, in this case, we're looking at the minor component as the relevant portion of what we're looking at. Going through all the alleles or all the loci with 4 alleles, and I think Mike had that in his presentation. It ranged anywhere from 3.2 up to 4.7, but the majority of them at the kind of the middle to smaller molecular weight were 3.2, 3.7, 3.9, and so that's for us that's below the 4-to-1, so we wouldn't separate out.
Could I ask why your lab adopted such a stringent criterion for separating out major and minor? I think many of our labs would have no problem.
Yeah, I mean, I think I saw that percentage up
What
there.
were the data that caused you to want to be even, I mean, this, to many of us would look at this and say it's an obvious major minor, and our protocols don't allow it. What were the data that led you to decide that was bad?
The German Stain Commission has their paper out where that's part of the whole thing. I think that's a type B mixture that they only separate out if it's less than or if it's greater than a 4-to-1 ratio. NIST has some data showing that if it's less than 4-to-1, what may be a major at one locus, when you get to the next locus, they've flipped on you. And so now what was the major is now kind of the minor. So if you try to start multiplying these across the board, you're not combining the actual genotype from a single person. You're actually creating this kind of composite profile.
Some of us should be rethinking that.
And again, at the higher end, this is a little bit less of an issue. That risk is lower, but you get down to the lower end where you're in the hundreds of RFUs, and that definitely is a risk.
Right, but in this game, we're not in that lower level, and maybe it's just the amplification kit that was not used, but there is a range even in this selective paradigm. And I think for that same reason, looking at what the German State Commission says, I would be nervous to not separate it out based on 4-to-1 because it can vary. You're basically taking an average of these 4 little loci. Some mixtures don't have very many 4 little loci, and so you're going to try to extrapolate that for all the loci. May not be an accurate extrapolation.
Right. I mean, you kind of have to use your best judgment of what what you think the real representation is. I mean, even here, at the small molecular weight, it's closer to 3-to-1. It's about 3.2-to-1, and then it kind of, as you get towards the higher molecular weight, it starts pushing closer to the 4-to-1, and even at the highest molecular weight, it exceeds 4-to-1. And so it looks like the minor component's kind of dying off as you're going towards larger molecular weight. So at some point, you're crossing from the 3-to-1 to a 4-to-1. Where that's happening in the middle, I'm not sure, so I was just going conservative, and I'm saying that since in general I believe it's probably going to be less than a 4-to-1, we just treated it as indistinguishable. So that was D8. Oh, yep.
How come 15-15 was not enough?
Did I see that note? Oops. I actually have a little note to that extent, so I would remember this morning. 15-15 wasn't possible due to the mixed ratio. So while 15-15 and the 12-14 would work as it has the right peak-height balances, especially for the 12-14, the mixture ratio is off too much. So we do kind of consider that as part of our interpretation. Yes?
So if the suspect was a 15-15, you would eliminate it?
Yeah. Because it's not it's not a viable option with our expectations. I mean, it's based on a validation study, everything else, that if we're looking at this and we say it's about a, mid-range 3.5 to 1 kind of ratio, and you look at that peak or that mixture balance, and that's, significantly off from that mixture balance, we would exclude them.
You were up on late one locus?
Yeah, I mean, that's the thing. I mean, we have to be comfortable. I mean, that's part of the thing is when you start doing this where you're doing your interpretation and you're documenting your interpretation before you ever look at your reference sample, you've got to be really darn sure about what your interpretation is, because you can't look at your reference sample and then go back and change that unless there's, a primer mutation or it's a triallele or something like that, something fairly rare. But yeah, you need to look at this and be comfortable that you are basing it on this and you're going to document that and go with it. And, I know at the higher end that it's really not going to range more than, like I said, if it's at 3 to 1 ratio, it's not going to go pretty much no more than a 2 to 1 or a 4 to 1. Now at the lower end, it can range from, a 2 to 1 up to a 6 to 1 or a 7 to 1. But at this higher end, I wouldn't expect it to vary that much. Yes.
Have you defined the range that you would accept for an evaluation? Like how far off is it actually before you get it?
Well, yeah, like I said, at the higher end, we give it kind of a plus or minus 1. So if it's supposed to be, if we calculate it out and it's about a 3 to 1, then we're going to go to a 4 to 1 to a 2 to 1. But even in a situation like this, where as it gets closer to the higher molecular weight, we see that it's moving more towards the 4 to 1, then we'd probably we might change that range there. I mean, there's nothing, the problem is you can't, with interpretation or mixture interpretation, have these hard and fast rules. So it still comes down to examiner experience and training. Yes?
What do you do for a 3% mixture? Would you ever call it a negative profile in a 3% mixture?
Well, you'd have to, again, we'd look at the loci that have 6 alleles, which are probably going to be fairly limited. And when we're looking at the minor component, we don't add up all, let's say it's 1 major potentially and then 2 minors. We wouldn't add up all the minors and compare that to the major. You would have to take 2 alleles of that minor component and see how that fits in with the major, because it's really, you're not going to have all the minors flip on you. It would be potentially a minor is flipping on you. So, yeah, we could potentially split out a major component from a 3-person mixture, but you're going to have fairly significant differences in your peak heights. But again, we don't see that at our lab, so it doesn't come up a lot, unless a gun fell in a pool of blood.
In a situation where there is a no suspect case and you attempt to interpret to go, do you all utilize codes?
Yes.
So what would you enter in to go, like as a search? Would you enter in all of the alleles, or would you, how would you all handle that?
In this particular case, yeah, I mean, I know there's the option of entering multiple variations of a potential profile. But again, with us, a lot of times, like a felon in possession case isn't even eligible for CODIS, so that's not really an option. We don't get a lot of underwear, unless a gun's wrapped in underwear. They use the underwear for the Molotov cocktail. Why someone would have a pipe bomb in their underwear, I don't want to know. So something like this, again, this is kind of unusual for me to actually see RFUs this level, but yeah, we would try to pull out as much as we can, and we'll get into this with a few of the other loci where it's a little bit more obvious, but where we don't have a distinct minor component, when you can limit it to 2 people, and when you modify your interpretation by limiting it to 2 people, you can start pulling out those 2 minor alleles, and you can pull out a distinguishable minor component with respect to that. But then you can also put in, maybe it is a 12-14, maybe it is a 14-15 at this locus. So you start putting in those variations. Are we good with D8? D21. So here we've got 2 alleles. So it auto-filled. There's multiple options, multiple combinations of 2 alleles. Can it be a 29 with the 29-30? No. Can it be and again, a lot of these are for mixture balance issues. Can it be a 29-30 with a 29-30? Yes. 2929 with a 3030, no. 2930 with a 3030, excuse me, yes. And then all these, the rest of them are dealing with dropouts, and there's no potential for dropout here. So then you go to the stat side of this, that autofills over here. So really the only options are 29, the only genotypic options are the 2930 and the 3030. For each of those, you do oh yes.
Go back to last slide. So you would call this the 2930 with the 2930?
That's one of the options, or 2930 with the 3030. And that basically translates, you still only have 2 potential genotypes that are contributors, but there's different ways you can get there. There's 2 different combinations that give you those 2 genotypes. So then you do the typical 2pq and the p squared plus p times 1 minus p times theta. You get your RMPs, and then you sum those down, and you get the 0.188 at this locus. Oops, sorry. Are we good with D21? Good enough? So then CSF. That's my CSF. Again, 2 alleles, actually a potential 3rd allele. I would have considered that. I look at that as part of the interpretation, at least looking at the 10 as a possible allele. It's not in the 2 allele thing because I really didn't, right off the bat, I could eliminate that just due to the mixture balance, because if you have the 10 and the 12, even assuming that 10 is 600 RFU, the range gets off. The mixture balance is too far off. So it comes down to the 2 alleles, the 11 and the 12. Can you have an 11-11 with an 11-12? Yes, and then all the others are no. Now in this case, since we're only looking at the minor component, the 11-11 isn't really an option because you can't have the minor component being 11-11 because that would mean the higher peak that just throws everything off. So while that's auto-filled, these cells would actually, well, this would actually be filled, and this is filled in the worksheet. This is where, this is a fairly basic tool. It's a spreadsheet that puts a lot of this information in there. But in a situation like this, you have to do a little bit of manual intervention, and you would delete out those cells because you're really only worried about the genotypes that have that 12. So then you do the 2pq with that. So at this locus, the RMP would be 0.217.
I thought you couldn't separate these out because it's less than 1.
Right. But in this case, well, that's a good point. Yeah. See what happens at 2 in the morning? It's also why you do tech reviews. No, you're right, because we weren't distinguishing this. I'd have to leave that in. I apologize. That's my bad. So then D3. The only option that's viable based on p-kite ratios for the 14-18 and the 16-17. And again, same issue. You really would have to use these. So ignore the blanks there and fill in the circles. But because we aren't distinguishing the minor component here, then you'd have to have whatever that 2pq is added to this, and then adding that down. I think there's one more with this. Then D18, again, we can ignore that pull-up peak. You go through, you've got the 2020. Yeah, well, we know where this is going. Sum that down. We good? Better?